This is the continuation or part 2 of the battle of the acids. So let's go ahead and take a look at the contents of what we have. In the first cylinder, we had what was called hydrochloric acid, HCl. And in the second one, we had vinegar. We'll get to the chemical formula of vinegar in just a minute because we're going to be turning these over, and I want you to record your information on that. Or you might be able to actually record it in the small space also down below here. What is the color and the pH? The color of the first one was reddish in color. And remember the second one was yellow, yellow, orange. We'll just say it was yellow. There's a definite distinction between the two. What was the pH of the first one? Well, according to this chart right here, the pH of red is going to be 1. So we'd say the pH equals 1. And over here, the pH for the yellow is going to be equal to 3.0. So this is a little bit better than the litmus test. It's not just telling us whether it's an acid or a base, it actually tells us what is the strength of that acid. And the question is, why is it that strength? If you remember, pH is the potential to hold hydrogen. And the higher your pH, the better you're going to be able to hold the hydrogen. If you remember acids like to give up their hydrogens. So this does a very poor job of holding the hydrogens, meaning it gives up most of its hydrogens. Here, this does a little bit better job, a little bit more potential of holding the hydrogens, which means that it's going to be a weaker acid. This is the stronger acid because it has a lower pH and it's going to be giving up all of its hydrogens. The potential to hold the hydrogens is very, very low. So that's explaining the acids and the bases. Let's take a look at the chemical formulas for each of these and what happens. So here's the first contents, and it's HCl. If you have HCl and you have this in water, as we did, we've done this in the lecture notes, the hydrogen from the HCl is going to be given to the H2O. So remember, acids like to give up their H pluses. So it's going to give the H to the H2O. What is this going to create? This creates H3O plus, and what's left over is the Cl, and that's going to be a Cl minus. So let's take a look at the second reaction, and the second reaction is the vinegar. So here's the HCl, and here is going to be the vinegar. The chemical formula for vinegar you will not need to memorize, but this is what it looks like. CH3 COOH. So here, the H from the HCl gets given to the water. Here, it's the H here that's going to be given to the water. So this is going to be given up to the water. And when the H combines with the H2O, it's going to create H3O plus. And then you have this other material left over. You have all of this minus the H, and it's CH3COO negative. So if you notice, we produce H3O plus in each of these. And again, this is what determines the pH. It's the H3O plus that determines the pH. So why is this a stronger acid? Because this gives us a pH of 1. This gives us a pH of 3. pH of 1 is a strong acid. pH of 3 is a weaker acid. But why is it weaker? They both are producing H3O plus. This is producing H3O plus. Remember, it's this that determines the strength of the acid. This is what determines the pH. So it's the H3O plus that determines the pH. So remember, H3O plus, this is like saying your H plus. So this is the acid. So here's the acid, here is the water, here is the molecule that determines the pH. Okay, same thing here. This is the molecule that determines the pH. Here's the acid, here's the water, here's the acid, here's the water. So again, the question, why is this one a lower pH? Why is this one a higher pH? Why is this a stronger acid? Why is this a weaker acid? When you put HCl into water, HCl actually is a covalent bonded material. There's a covalent bond between them. But when you add it to water, what happens is it turns into ions. It turns into the H plus and the Cl minus, and the H plus will attach itself to the water. How much of it is very, very important, because 100% of the molecules fall apart. So it's said that you have what's called 100% ionization. This means every HCl falls apart. Every HCl is going to fall apart into H plus and Cl minus. Falls apart into H plus and Cl minus. However, vinegar is not the same. What happens here is you only get about 10% ionization. What does that mean? Well, it means that 90% of this molecule stays like this. 90% stays. So when we get 10% ionization, that means the vinegar falls apart. So that means 10% of the vinegar falls apart and produces H3O+. 90% of this molecule actually stays as vinegar. So going back to here, the HCl, 100% ionization. Every molecule falls apart. At the end, we have 0% HCl at the end. 0% HCl in the end. And that's because it has all fallen apart into H plus and Cl minus. It's very different with the vinegar. Only 10% of the original vinegar molecule, which is this right here, ionizes or falls apart. 90% of it stays as vinegar. So what does that mean in terms of the H plus? Well, remember we had equal molar concentrations. We had 1 mole here, we had 1 mole here of the vinegar and of the hydrochloric acid. But if every single one of these falls apart, what's the concentration, or how much of these are we going to get? We are going to get lots of H3O+. If only 10% of these molecules fall apart, how many of these H3O+ are we going to get? We're going to get very little H3O+. So remember, it's the H3O+ that determines the acidity. This is the H+ concentration. Okay, so this gives us 10%, this gives us 100%. So if we started off with 100 molecules of this, we have 100 molecules of H3O+. If we start off with 100 molecules of this, we only get 10 molecules of the H3O+. And since this is what determines the pH, we have more molecules, more of the H+ present here because it has all fallen apart. We only have 10% of the molecule over here. So this makes HCl a stronger acid because it all falls apart. Some acids are weaker acids because they actually don't all fall apart. 90% of vinegar stays as vinegar, and only 10% of it will produce the H3O+. This is the battle of the acids. This is why HCl is a stronger acid, because it all falls apart versus vinegar, which 90% of it stays as vinegar.